Okay, so they say three times a charm, or the third time's a charm. I've tried this a couple of times. Let's hope that this one keeps taping. We are now in lesson 10-1, exploring quadratic graphs. Okay, so we've been working with quadratic functions for a while. We have been factoring them. So we're going to look first here at the standard form of the quadratic equation is y equals ax squared plus bx plus c. Of course, we know that there are variations of that with negatives and positives, but this is the standard form of the equation. We're going to be looking today at the quadratic parent function. Parent function is the simplest form of any of the functions, and so in this case, the quadratic parent function for a quadratic is y equals x squared, or we can say f of x, the function of x, is equal to x squared. And that is the parent function. So let's look first at the graphing of a quadratic. I'm afraid that when I move things, that's when my taping stops, so I'm going to be very gentle with moving things. This is the graph of a quadratic function. It is in the shape of a parabola. Parabolas are symmetrical, so there is always an axis of symmetry. In this case, we are looking at the y-axis as the axis of symmetry, and then we have these symmetrical sides. If I were to fold this over, it would be exactly the same. So this is what we are going to be looking at. We're going to be looking at the parabolas. So let's talk about the other parts of this parabola, sliding a new sheet in. Okay, now this is a parabola that opens downward. It has a vertex which is called a maximum. It's called a maximum because it is the highest point of our parabola. That maximum, our vertex, is at 4, 3. Here is our axis of symmetry. The axis of symmetry is actually at x equals 4. Okay? Now let's look at 1, moving this very gently. Okay, so here we have, of course, a parabola that opens upward. It has also a vertex at -3, -3, so that is where our vertex point. This is called a minimum because it is the lowest point of our open upward parabola. Here is our axis of symmetry, and that is at x equals -3. And so this is going to be the form of everything that we graph. Now, let's look at actually graphing one of these. I'm still moving very slowly so that the camera doesn't want to jam on us. We are going to graph f of x equals -2x squared. And here I've made my chart, okay? I've made my x, my -2x squared, and then here are my points. I have put in 3 points, 0, 1, and 2. I know that my vertex, and we'll, as we go further, we'll understand that our vertex is going to sit on the 0, 0. We're going to go ahead and place that point. I have 1, -2. Go to 1, -2, and 2, -8. 2, -8. That's 4, 6, and 8. Okay, now because I know that my parabola is symmetrical, I'm just going to place my second points, and then I am going to build my parabola. Now, remember, this is a curved bottom here. Remember when we were working with our other graphs, our, oh Lord, words are escaping me. We just don't want it to be a V here because that's going to look like an absolute value graph. Okay, so So that is basically how we are going to look at graphing these by assigning points. Let's talk about the width of our parabolas. Okay, moving in another paper, just very slowly and gently. Okay, so we have, here is our parent function graph, y equals x squared. Now notice that when we are looking at y equals 4x squared, our parabola becomes much more narrow. And then when we are looking at 1/4 x squared, our parabola becomes very wide. These are just tips to help you so that you kind of have an idea of what type of parabola you are looking at. Now notice we aren't working with anything but that ax squared part of our quadratic. What happens when we actually start working with a c in our quadratic? Well, I'm going to show you that. Here we have, once again, our parent function graph here, vertex at 0, 0, okay? Here is what happens with our c value. Our c here is -4. You'll notice that my vertex point has moved down to -4. And if you were to look at the points, looking at, what happens here, let's look at when we put a 1 into this. So we would have 1 squared minus 4, which would be 1 minus 4, which would equal -3. Okay? And here, when we put the 0 in, okay, 0 squared minus 4 is, of course, equal to -4. So when we have a c, we move the vertex down or up. If this was a +4, I would be moving it up 4 spaces, and my vertex would be at this point and opening upward. So these are just the very basics. We're going to be doing some graphing and just kind of keeping it light for our first day back. I didn't want this to be a really stressful video for you. So hopefully it's all understandable, and we will go over more of it when we are together. Okay, thanks. Bye.